All right, we are back now to talk about VLANs, virtual LANs, virtual local area networks. We just talked about CDP and LLDP and how you would discover devices, and now let's talk about VLANs on how you would actually put those devices into VLANs. After we talk about VLANs, we'll also talk about access ports and trunk ports for routing these VLANs into different places. So first of all, how do VLANs actually work? Well, VLANs are basically creating a little mini switch on an existing physical switch. So let's say that you have, actually let me pull up the whiteboard here so I can go through this, draw out a nice, let me get a actual brush here. I'm going to draw out a little switch here, and let's just draw some ports on the switch. Alright, so we have 5 ports here on the switch. We can essentially, if we want to, have 5 different local area networks corresponding to those ports, as long as we put those ports in a different VLAN. So maybe we want to say that this first port here is going to be VLAN 100. And maybe the second port is going to be VLAN 200. Maybe this third port is also going to be in 200. And let's use this color, VLAN 300, and then we'll go ahead and put this last port as an open port for right now. So we'll say we have 3 VLANs now on the switch that are defined: VLAN 100, VLAN 200, VLAN 300. So we are now basically saying that this switch is 3 switches in one, essentially. We've given the VLAN 100, that's its own separate broadcast domain. VLAN 200 is its own separate broadcast domain, and the same thing with VLAN 300. Now, any device that's connected to that switch is now technically considered to be a part of the VLAN that's configured on the port. So these 2 VLANs here, if I go back to this color here, VLAN 200, those 2 ports can technically talk to each other, the devices on those ports, that is. So if there's 2 computers there, they could be in the same network, and then they can access each other depending on the security settings, of course, and all that other stuff. But at a fundamental network layer, those devices are able to speak to each other because they will be on the same broadcast domain. Now, VLAN 100, VLAN 300 cannot natively talk to VLAN 200 unless there's something in the middle to make that happen, and that's where we get routers. That's why we need a router. We need to route between networks. So since we've created these 3 different subnetworks, or 3 different networks that are on the switch, we need to somehow route between those networks, and then that's where we're going to have a router come into play for us. So before we get to that, though, I want to talk a little bit about voice VLANs and data VLANs and what the difference is between those 2. So we just have a VLAN on the switch here, and normally you might just see that called an access VLAN or a data VLAN. Now, the concept of a voice VLAN applies specifically to phones, of course, as you would imagine, but it's going to be involving the subnet or network that's going to be used for voice communication only. And so you have a port on the back of your phone that has the possibility of being connected to a computer, and that computer then would be assigned to an access VLAN. So the access VLAN would be assigned to maybe VLAN 100 here is the access VLAN. So that would be switch port access VLAN 100. That would be your PC that's connected to that port on the phone. The voice VLAN we haven't defined here. So that would technically be in the same VLAN, VLAN 100. If we wanted to, on this same port that has VLAN 100, we could say voice VLAN. I'll just say VVLAN for short, and I'll say maybe 101. So now we've got 2 VLANs assigned to the same port. This one's for data, this one's for voice. So we have VLAN 100, switch port access VLAN 100 would be the data port assigned to the phone, and VLAN 101 is going to be the port essentially assigned to the voice communication there. So no other devices are existing on VLAN 101, so there's no voice traffic that can exist going back and forth on the switch yet. And like I mentioned, this is where we have our routers coming into play. So let's draw a router over here. Make sure I don't draw it behind me. So this, let's say this is R1, for example, and this maybe is SW1 in the IP expert topology. Now, I left this port open intentionally, as you may have guessed, to be a trunk port. A trunk port is going to have the ability to manage multiple VLANs and pass multiple VLANs across that port. So unless I explicitly deny the ability for those VLANs to pass. So if I wanted to create routing between these VLANs, I would need to have some type of trunk port that's going to let me route those VLANs to a routing device, such as a router. So if this is a trunk, we have a couple different trunk options. Of course, since we're using 802.1q encapsulation, this would be an 802.1q trunk. Alternatively, we can do an ISL trunk, but might as well just do an 802.1q, make it easier on yourself. That is the most common one that's going to be used. So we have this port here as an 802.1q trunk. All we've done here is just define it as the mode of the port. It can either be an access port or a trunk port. Of course, I didn't really mention it, but these guys here are access ports. And this would be a trunk port here that we're assigning. So we're saying the trunk port then is going to be connected to the router. So if we just say switch port mode trunk, and also we need to define the encapsulation like we said, 802.1q. Once that's defined, and once we say the mode trunk, now we technically have the ability to create a trunk port with the far end device. And that far end device could be some type of router, or it could be another switch, of course. You'd be trunking between switches. So in this case here, this is going to be a router. So we're trunking up to that device, and now we have to somehow, on the router, be able to route between those devices. And a common way that you would see that done is with what might be referred to as router on a stick. You might have heard that term before. So, and the reason why is because it essentially looks like a router on a stick. You've got a router over here, and you've got, see if I can do this with the colors. You've got all these different VLAN colors coming into the router on the same port, mind you. And all these VLANs are going to be on the same port right there. And so it kind of looks like a router on a stick, right? So that's where the term comes from. Anyway, it kind of helps you remember at least what it's doing. So obviously you can see if all of these different VLANs are trunking to that router, all of them can route between each other, provided that the router has a configuration to do so. Now, on the router, since they're all coming into the same port, you're going to need something called a sub-interface. The sub-interface is going to define which VLAN it's going to route the traffic for, and also the IP address and subnet mask that you're going to be assigning to that sub-interface. So this is probably a good time to look at the configuration, see how that actually looks. So let's pull up R1 over here, and even before that, let me go to switch 1 and show you the trunk port that we have configured. If we do a show run, actually, let's pull in CDP a little bit and see if we can figure it out. Show CDP neighbor from switch 1. And we've got several devices on here, but we do see that R1 is located on fast Ethernet 101. So that means if we want a trunk on that port, we got to configure FA101. So let's look at that configuration. Show run int FA101. And we've got switch port trunk encapsulation .1q. So we've defined the type of encapsulation we're going to use on the trunk port. We've also defined that it is in fact a trunk. So that really is all the configuration that we need. Now, very important item that we need to cover here in terms of configuration is to make sure that this worked. Anybody can just configure it. What if the port is accidentally shut down? What if you don't really know it before looking at the configuration? There's a couple ways you can actually verify what you've done. The best way, I'd say, is to do a show interfaces is what it comes out to be. Show interfaces trunk. Hit enter, and you can see whether a port is trunking or not. And this one is, in fact, trunking. So we have FA101 mode on, encapsulation.1q, and it is trunking on the native VLAN 1. Native VLAN is simply going to mean it is untagged. We're not tagging anything with VLAN 1 in this case. So if anything comes into the switch without a VLAN tag on it, it can be considered as VLAN 1, is what we're saying here. Now, if we scroll down through the rest of this configuration output, we've got port and VLANs allowed on the trunk. This is very, very important. You can see already kind of the wheels turning, maybe like this could be a possibility for them to kind of screw us up here. They could say, well, you know what I'm going to do is I'm going to turn off the capability of passing a specific VLAN. And now you won't be able to pass traffic for that VLAN because it's specifically disallowed at the switch port level. And you can easily see that with the show interfaces trunk command. And in this case, you see that it's able to pass VLANs between 1 and 4094. So we're good here if we're within that range. And then we can see even below that which VLANs are actually active and allowed in the VLAN management domain. So if we assigned VLANs to our ports somewhere, you can see which VLANs are going to be able to be passed on this trunk port. So we've got, of course, the native VLAN 1, we've got ports or VLANs 11 through 13, VLAN 100 and VLAN 199 is able to be passed there. So, okay, so if those fall within our range, we're good there. So, of course, we'll look at the access port configuration as well here, but we know now that our trunk port is good to go. We've got that trunking established, and we are ready to connect to the router. So let's go look at the router now. So let's do a show CDP neighbor here again. And we've got switch 1 on gig 00. So if we look at gigabit Ethernet 00, we see that there is absolutely no configuration on there. Now, if I wanted to put a configuration on here, I could put a configuration for the native VLAN. Because remember, if it comes in untagged, it's going to be coming to the main port essentially. You haven't defined any sub-interfaces. We haven't actually defined sub-interfaces here yet either. I mean, I've got them in the configuration, but I just haven't shown them to you. But moral of the story here on gigabit Ethernet 00, if any traffic comes in there, it's going to be untagged. And so we don't have any IP address, we have no communication possible there at layer 3 for any untagged frames. So we're not supporting the native VLAN here in this case. So if we just do a show run begin interface, we can kind of see here the different sub-interfaces that we have on the configuration. So once again, this is the main interface, gig 00. We've also got gig 00.11. This number here does not make a difference whatsoever in your configuration. It's just a nice little helper. I could say gig 00.400 and then assign encapsulation .1Q11 for VLAN 11. This is assigning VLAN 11 to this port, and I've made the subinterface .11. So it's probably a great idea for you to do that if you're trying not to confuse yourself. So probably a good thing to do there. So encapsulation .1Q11. We've got an IP address on here as well. That's 10.10.11.1, and it looks like it's a /24 here, so 255.255.350. So that's going to be supporting VLAN 11. So now that means that anything that's in VLAN 11 may or may not use this device here as its default gateway to get out. And in this case, that's what's happening. The next interface here, we're going down to subinterface gig 00.13. This is going to support the servers in the IP expert topology. We've assigned it to VLAN 13, and we've given an IP address. So that means now that VLAN 11 can talk to VLAN 13 because both know how to get to each other. They're both connected to the router. So they both have a route to that destination. And then once again, we have this VLAN 100 here, encapsulation .1Q100 assigned to this port. So these are the sub-interfaces. This is creating that router on a stick scenario that we talked about in this scenario here. So we've got the router on a stick configuration set up. We've got the trunk port set up. I didn't actually show the access port, but we know that those are set up based on the VLANs that are allowed and active in the management domain. But let's go back and look at the actual ports themselves on the switch. This is now switch 1. So if we do a show CDP neighbor, we see that the local phones to me, of course, we have rack phones here at 1011 and 1012, but the local phones to me are 1013 and 1014. So we know now that we can configure those as access ports and also can assign a VLAN to those access ports and either voice or access VLAN. So if I do a show run interface fast Ethernet 1013, you can see that we have switch port access VLAN 12, so we're assigning the data VLAN 12, and then we're also defining that as an access port. And then now we're saying that this switch port should also be in voice VLAN 11. So that means that any phone that is on this port is going to be in voice VLAN 11. Any PC that's connected to that phone is going to be in access VLAN 12. And then, of course, the last thing we have here is port fast, which is going to enable that port to skip all the spanning tree, listening, learning phases and so forth, so the port doesn't get blocked by spanning tree. And so it just doesn't take 40 seconds to come up, I think is what it would take. So that skips all that. It's probably a good idea to put that command in there as well. So another thing too, so we've got our trunk port, we've got our router 1, we've got our access port configuration now. Everything is configured correctly. Now, if I wanted to verify my access VLANs, we can go through and look at the configuration with a show VLAN brief command. And that will show you all the ports on the switch and what VLAN those ports are in. So if you do a show VLAN brief, we've got VLAN 11 here. It's actually named HQ phones. And I'll show you how to do that as well. We've got ports FA1013, ports FA1014 in that VLAN. And you can kind of go through and see how each of those are assigned. So that's great. If they're not assigned here, or if perhaps the VLAN is inactive, then you've got some kind of configuration error on your switch there. So let me move over to, I have a couple slides on this and maybe somewhat review at this point since I've kind of ran through all this configuration. So the one I wanted to touch on for sure is the name of those VLANs that we saw here in the actual show VLAN brief command. So we've got show VLAN brief, we've got our VLANs, we've got our names. This is how you actually configure your VLANs on the switch. You can say switch port access VLAN 11, and that VLAN will get added to the switch right there. However, you don't have the opportunity to add a name unless you're doing it from the global config mode. So you do this VLAN 11 from global config mode. Now it takes you into config VLAN mode, and now you can say, I want to name this VLAN phones, or I want to name this VLAN data, or whatever else it asks you to name it. Of course, we're doing all this based on whatever the requirements are in the lab. Remember, our focus is always going to be, what does the lab say? What do we want to do based on what the lab says? So we're naming this VLAN phones. We're also at the bottom here, this is something else that I didn't mention, we can add a switch virtual interface to the switch. And what we do here, interface VLAN 11, this is saying create a layer 3 interface in VLAN 11. So that's giving us an opportunity to address our switch layer 3 wise with an IP address in that specific VLAN. So we've given it 10.10.11.3 here, so that way you can access the switch using that address. So that's all that's really doing there for us. Another thing I want to point out here is this show VLAN brief is going to work on your 3750 switch, of course, but if I go to our routers that also have phones connected to them, and I do a show VLAN brief, it's not going to work for us because the command is just slightly different. It's actually going to be a show VLAN-switch brief. And so it's going to give us the same information, but just to trip you up, Cisco decided to say, now let's make it show VLAN-switch brief instead. So make sure that you know the difference between those commands. That's what the deal is here. We're seeing the same information. These are actually named the same way, and you can do it the same way from global configuration here as you could have done in the 3750. You've got the couple ports that are assigned there as well. So nothing out of the ordinary there. It's just that the show VLAN-switch brief command is different. So coming back to the presentation here, we've got verifying VLANs. We just talked about this, show VLAN brief, and then there's show VLAN switch brief. So just a couple differences there I wanted to make sure I highlighted. Access port configuration, once again, we've got the differences between a switch, the actual 3750 switch, and an ether switch module on a router. You can see they're not very different at all. I mean, we've just got switch port access VLAN 12, switch port mode access, so we're saying on the 3750 we're defining the mode that switch port is going to operate as. It's either going to be an access port or a trunk port in this case. And we have switch port voice VLAN 11, so defining the voice VLAN, got spanning tree port fast, we're looking good there. Now on a router ether switch module, we're doing the same thing. We're defining our access and voice VLANs. This no IP address command that's in there is actually in there by default. That's not something you have to type, but it's basically going to operate as a layer 2 port by default. You don't see switch port mode access right there at all, so it's going to be an access port. And then last thing, spanning tree port fast, of course, we're going to add there. 802.1q trunks, we talked about this already. I'm going to move quickly through that and also get out of the way a little bit, if I can. Okay. So we obviously have our physical interface there and the two sub interfaces. One is going to be in VLAN 11, one's in VLAN 13. And then the router configuration is going to be trunking to the switch in this case. So that's what we're doing here on the .1Q trunks. Trunk verification, show interface as trunk. Once again, a very important command for you to know about. And here is the router configuration or verification as well to see that those are actually up and running. Just the show IP interface brief command, which you should pretty much be familiar with at this point. I did have in here the exclude unassigned, so that way you can see only those interfaces that have IP addresses assigned to them. So that's what we're doing here on the trunk verification. Okay, so that's all I want to talk about with VLANs and access ports, trunk ports. And the next section we're going to cover is we're going to talk about DHCP, and then we'll also talk about NTP in our infrastructure services section. We'll see you in the next video.